Just a quick recap before we get stuck into this. If I had some data 1, 1, 1, 4, 10, and to work out the mean, I would add them up and so that would be 14, 15, 16, 17, and I would divide by the total frequency, the number I have, and then I'd work that out and I get 3.4 in this case. Now it's possible to represent this data, this raw data, in a frequency table. So here I would have like my X value, and then I'd have my frequency at which it occurs. So I've got 1, 4, and 10. I've got 3 lots of 1. I've just got 1, 4, and 1, 10. Now how would I work out the mean from this? Well, I could do exactly the same thing. I've just got to remember that what this means is that I've got 3 lots of 1. So I could do 1 times 3, and that will give me 3. And what I've essentially done in one step is add those ones together. And then I've just got 1 lot of 4, so that's going to give me 4. And I've got 1 lot of 10, and that's going to give me 10. And then I could add these up back to 17. But what do I do now? I'd have to divide by the total frequency. I'd have to add the frequency up. So I'd still do 17 divided by 5. It's just I've got to remember that this is how I do it, okay? I'm not going to divide by just the number of numbers that I have. It's the frequency that I'm interested in. Fast forward to grouped frequency. This is even just an extra step needed for this, but actually it's very similar if you've understood that concept. We now have 6 customers between 0 and 3 minutes. Some of them might take in 1 minute, some of them maybe are really close to 3, and so on. What if we averaged that out and said, well, maybe there's a number that I could kind of treat all of this group as? And that's where we use the midpoint. So for 0 to 3, it's going to be 1.5 is going to be my midpoint. Some will be more than 1.5, some will be less, but we can kind of treat it, this middle number, as representing that group. We can do the same for the other ones. This will be 4.5. What I'm doing is I'm seeing there's a gap of 3, and then I'm just halving that to give me 1.5, because then I know I just need to go 1.5. Instead of all the way to 6, I just need to go half the distance, and I'm going to go to 4.5. This, and because all the groups are 3 actually, this will be very quick. This will be 7.5. By doing 6 plus 1.5, this will be 10.5. This will be 13.5. Another way you can do it is you could add these two together and divide by 2, and that will also give you the middle number, which is 13.5 in this case. You could do that for all of them if you wanted. Alright, I've essentially turned my grouped frequency table into a normal frequency table using like an approximation, an estimate. So what I do now is I say I've got 6 customers that all had 1.5, so I multiply those together. So I'm doing midpoint times frequency. I've done frequency times midpoint, whichever way you want to see it. 10 times 4.5, I've got 10 lots of 4.5, that's going to give me 45. 6 times 7.5, that also gives me 45. We can use a calculator for this if we want. 2 times 10.5, 21. 1 times 13.5, 13.5. And do the same again now. I'm going to add all my frequencies together. So 16, 22, 23, 24, 25. That's how many people I've had. But then I'm also going to add these numbers up. 3 plus 4 plus 10 gave me that. Okay, now I'm going to have to add my midpoint times my frequency. And this is definitely a point at which to use a calculator. Okay, sorry, I didn't quite have it loaded up. Just bear with me. All right. Yeah, new update, brilliant. 9 plus 45 plus 45 plus 21 plus 13.5 equals 133.5. So now I'm going to go for 133.5 divided by the total number, total frequency, okay, because that's what we're doing. We're just doing our definition of the mean. Answer divided by 25 and I get 5.34. Now, I would probably write my answer as 5.3 because I think like you can't really say that's very accurate. It's a bit meaningless because it's an estimate. But I think it's okay to round it. You'll probably get away with writing the 4 down as well. Now, I've given myself the marks already. I think I'm right. But I think one last little check is just to check, does it seem realistic? Well, it's got to be greater than 0. It's got to be less than 15 because we're looking at the mean. It's kind of about halfway through, but it's weighted towards the lower end, as we can see. So 5.34, just looking at it seems to make sense. If you got like 12.1 as your answer, I'd be very suspicious because there's only one bit of data that is more than 12. So do take a look at your answer. Don't mathematically just like think, oh, this is the method, this is what I have to learn. Think, reflect on it as well. Because this later question I've already actually given the answer to it, but it asks you to, it's asking more about the understanding of what's going on. So explain why it's not possible to use the information to calculate the exact value. We have something to this effect. We have grouped data not raw data, which is exact values. I think that's enough.